Hello student, welcome again our channel in the physics point. Today I have discussed the next concept about the physics which are missed in the previous lectures. In this lectures we have started discussions of the second types of the physical quantity, that is the types of physical quantities. We want to explain the such types of the physical quantity. We needs the proper explanations of that certain physical quantities. Physical quantity, it means every measurable things in the universe. This is known as the physical quantities. The first type of the physical quantities, it is called, it is scalar physical quantity. I will be talk about the scalar physical quantity in the previous lecture. That is roughly talking about the scalar physical quantity. The physical quantity which needs only magnitude or numerical value for the proper explanations of such physical quantity is known as the scalar physical quantity. It needs only magnitude for their proper explanations of the physical quantities. These such physical quantities known as the scalar physical quantity. For the examples of this, that is distance is the scalar physical quantities. Distance is physical quantity which will be discussed in the previous lectures, but how the distance will be included in the scalar physical quantity? Because consider a point A and point B. Whenever object is traveling from the point A to the point B, they are covered such a distance, that is 5-meter distance. But for the explaining the distance, we have only, or we requires only the numerical value about that particular physical quantities. This is only numerical value, that is 5 meter. It must be numerical values. This is known as the scalar physical quantities. Again, the length, or again the mass is must be the scalar physical quantity. A volume is must be the scalar physical quantity. It does not needs any directions, or it does not needs any knowledge about the directions for the proper explanations of the distance, for the proper explanations of the mass or the volume. These physical quantities included in the scalar physical quantities. Another one physical quantity, the second types of the physical quantities, the vector physical quantities. It is the vector physical quantity. The physical quantity is needs both magnitude, it means the numerical value, as well as the directions of that particular physical quantities. Is this such physical quantities known as the vector physical quantities? It needs both magnitude, it means the numerical value, and directions, and the directions of the applied physical quantities. Consider a force is applied on the certain object. This is a box. Consider this is a box. I will be apply certain force on that particular object or on the particular box. The box will be moving in this particular directions. In that direction, it means I will be applied certain force on that particular direction. It means the amount of force is must be 10 Newton force applied on that particular object towards to left to the right, or towards to the right, or towards to the point B. It must have the knowledge about the numerical value, it means the magnitude, or it also have the knowledge about the directions of that particular physical quantities applied. That is the it both needs magnitude as well as the directions. A vehicle is situated at a point A, and the start these vehicles is moving towards to the B, having the certain speed, that is 50 kilometer per hour. The speed of that particular vehicles is 50 kilometer. This is the speed, and speed is also the scalar quantities. Speed is also the scalar quantity. It does not needs any knowledge about the directions. It does not need any knowledge about the directions for the explanations of the such physical quantities. This physical quantity is known as a speed. Speed explain करण्यासाठी कुठल्याही direction सांगायची गरज नाही. A vehicle is moving with a certain speed. This is their numerical value, or this is must be a scalar quantities. But what about the velocity? Velocity is a change in displacement with respect to time. Displacement is needs the knowledge about the directions, how to displace the object towards to left, towards to right. I will give the examples in the previous lectures. Now the 10 Newton, the 50 kilometer per hour speed, the vehicles is moving towards to point B from the point A. The vehicles is moving with the speed 50 kilometer per hour from the point A to the point B. 50 kilometer is the numerical value of the speed of that particular object, but when this object is moving from A to B, this shows the directions. It means the velocity is the example. Velocity is the examples of the vector quantity, as well as I will explain previous example, that is force is one another examples of the vector physical quantity. In the previous lectures we are reach up to the velocities. Velocity, it means the rate of change of displacement with respect to time. This is known as the velocities. And speed is the rate of change of distance with respect to time. This is the speed. Then I will give you one of the formula in the previous lecture as same positions in the on the board. That is, distance is must be equal to speed into time. This formula is mostly useful for a lot of competitive examinations, or this is help to solving the lot of questions from the different types of the competitive examinations in must be mathematics or physics also. The distance is equal to the speed into time. Okay, the next concept will be discussed start from this lectures. That is, the next concept is from the motion, that is acceleration. The next concept will be, that is the most important concept, acceleration. When the rate of change of displacement with respect to time to form the velocities, but the rate of change of velocity with respect to time to form acceleration. It is the rate of change of velocity with respect to time. With respect to time is called acceleration. Is called the accelerations. The accelerations is denoted as the letter A. The acceleration, consider the vehicles at a point A and moving towards to at a point B, and the certain different places, the place 1, place 2 and place 3 from the on the path from the point A to the point B. Then I will be taking the reading of my vehicles at the point B. The velocity will be V1. The velocity at the point 2 of the particular vehicles is a V2, and the velocity at the point 3, this is the V3. But the time will be also measured at the point 1, that is a T1. Time is also measured at the point 2, that is T2, and time is also measured at the particular time is T3. It means the velocity is continuously changes from the point A to the point B. I will be taken a 3 different reading from the 3 different place 1, place 2 and place 3. The velocity and time at the place 1 is V1 and T1. The velocity at the velocity and time at the point 2, that is V2 and T2. Velocity and time at the point 3, that is V3 and T3. What is the accelerations? Accelerations A is equal to change in velocity with respect to time. The velocity is V2 minus V1. The velocity will be changes because V1 is not equal to V2. Velocity are changes when the bikes or when the vehicles is moving the point A to the point B, that is the T2 minus T1, that with respect to time. Consider the vehicles or V1 is equal to 50 kilometer per hour speed at the directions from the point A to the point B, and V2 the velocity must be increased. Velocity will be increased the 70 kilometer per hour. Then V2 minus V1. The time at the point that is T1 will be 10 minutes and T2 will be 20 minutes. 10 at the time 10 minutes and T2 will be 20 minutes. It is the difference between these two times will be delta T. They are again called dV upon delta T. In the proper explanations or the physical explanation, that is dV upon dt. This is the high level, or this is the level up to the 11, 12 standard or the junior college standard. But in up to the 10th standard, the explanations about the acceleration is I point out that if the velocity will be increases, the acceleration is increases. The acceleration is produced, the acceleration is a positive value. And the velocity will be decreases. The vehicles is reduce their speed up to increasing the time. Time must be increases, but the speed of the vehicles will be decreased. It means the velocity of that particular vehicle is decreases. It must be the final velocity is less than the initial velocity. The final velocity V2 is less than the initial velocity. It means the numerator is a negative value. Then acceleration is must be negative. And if a vehicle is moving a constant speed, vehicles is continuously moving a constant speed, doesn't changes their velocity, it means the V1 equal to V2 equal to V3. Then V2 and V1s are equal in values or equal in amount. It means the numerator will be 0, because the subtraction from the same value is must be 0. The numerator will be 0. The acceleration is 0. Then that's why we are discussing the new concept, that is the types of acceleration. The first type is the positive accelerations or positive accelerations, and second type is the negative acceleration. This is also called as retardation or de-acceleration. The negative part is retardation, negative type is retardation, de-accelerations or negative acceleration, and third part is the zero accelerations. It does not changes any velocity when the vehicle is moving from the initial position to the final position. Then we take in the part acceleration does not forms. It means this acceleration is a zero accelerations. Okay. Okay, now types of accelerations. The second concept will be types of acceleration. The first one is positive acceleration. First one is the positive acceleration. When the final velocity, the conditions for the positive acceleration, final velocity is greater than the initial velocity. The positive acceleration, it means the A equal to comes positive values. A must be positive values. Then acceleration A is equal to v2 minus v1 divided by t2 minus t1. If this acceleration is a positive accelerations, AP, use the suffix P for the positive accelerations, it means v2 is must be greater than v1. For the positive accelerations, v2 is must be greater than v1. What is the unit of the accelerations? What is the unit of accelerations? Then the unit is must be, that is the unit of velocity upon time. The acceleration is change in velocity with respect to time. It means the unit of velocity is the meter per second, and unit of time is must be second. Then the unit of acceleration is meter per second square. This second is comes to denominator and multiply with the another 1 second. Then the meter per second square is the unit of the acceleration. Then another one part is zero acceleration. Second type is zero acceleration. That is, in this condition, v1 is equal to v2. v1 equal to v2. Then A is must be 0. This is the zero acceleration. If the initial and final velocity will be same, this initial and final velocity is the same of that condition when the vehicles is under the uniform motions. Vehicles is under the uniform motions. At that times, the velocity of the initial velocity of the vehicles and the final velocity of the vehicles are same. Then third one part, that is negative acceleration. Negative accelerations. The negative acceleration, it means the final velocity is less than the initial velocity. Exactly reverse conditions of the positive acceleration. Negative acceleration is exactly reverse. Then the final velocity is less than initial velocity. Final velocity is the less than initial velocity. Then for these conditions, the inner acceleration is formed. This acceleration is the negative acceleration. It means the A is a negative value. A will be negative value when the v2 is less than v1. v1 is the initial velocity, v2 is the final velocity of the vehicle of that particular object. Then in the next lectures we are discuss the detail about the uniform and non-uniform motions and the circular motions. But today's lectures, I will promise yesterday lectures. Today's lectures we are discuss Newton's laws of motions. Let's start the discussions without wasting the time in the next concept, that is Newton's laws of motion. Newton will be described three different laws about the motions and the relationship between the motion, force, or speed of that particular object, or the activities of that particular objects which are under the motions. And we are taking certain examples on that particular. Please take the heading. This is the most important concept for each and every types of the students or each and every examination, that is Newton's laws of motion. Newton's laws of motions. The Newtons will be described the three laws about the motions of that particular object, and they are said the detailed information about the certain force or certain changes of their positions. The first law, Newton's first law. First law. Every steady object or every object which are under the steady state, it must be steady state, or every object which are under the uniform motions, they are still uniform motions until and unless applying the external unbalanced force. Consider the particular dusters. When the dusters must be steady states, they does not changes their positions. What is the difference between steady and motions? If the object which are changes their position with respect to time, then that object is under the motions. But these dusters does not changes their position. It must be, this is in the steady motions. It does not changes their motion. That does not changes their steady states, because when, until and unless when applied the unbalanced force or external unbalanced force, whenever I will apply the external force, then these particular dusters will be changes their positions. Then this is all about the first law. Consider a vehicles in the uniform circular motion, in the uniform linear motions, when they does not changes their motions or they does not stop until and unless the external unbalanced force. Balls which comes towards to the wicket keepers, when the balls will be thrown from the bowlers, then the speed of that particular cricket ball is the same or in the uniform state after, before the taking a catch of that particular wicket keepers. Then when the wicket keeper will be taken the catch, he will be applied the external unbalanced force to stop that particular speed ball or that particular balls which are under the uniform motions. It must be which in a steady or stationary state remains steady state, or the object in uniform motion. Uniform means the velocity of the velocity of that particular vehicle's velocity of the particular object which are under the uniform motions are same each and every point. Uniform motions still in it until applied the external unbalanced force. External unbalanced force. Every object there are in the steady state, it remains in the steady state, or every object which are in the uniform motions, it must in the uniform motions until and unless whenever we applied the external unbalanced force. I will give the examples on the hands, or examples of the duster on the hand, or examples of the duster on the table. It remains in the steady state whenever the external man comes to take the duster for the rubbing the boards. This is must in the steady state. I will give the examples of that particular balls which are comes towards the wicket keepers. When the wicket keepers does not insert their hand in between the path of their motions of the object or motion path of the motions of the ball, then the ball is doesn't stop. It goes towards to the backward directions or the boundary directions. When the stop of the motions of that particular ball, the wicket keepers insert their hands or it are applied certain force on that particular balls. This is the first law. And another one is second law. Second law. Before the discussions of the second law, we must have the knowledge about the momentums. What is the momentum? Momentum, it is the product of the mass of the object and to that the velocity of that object. Momentum, it is the product of mass of that object and the velocity of that object which are under the motion. Momentum, it is the product of mass and velocity of the object. The momentum which are denoted by the letter P, the P is equal to m into v. This is the linear momentum. P is equal to m into v. M is the mass of that object and v is the velocity of that object. M is the mass of that object and v is the velocity of the object. The object under the motions having the speed, having the velocity v and having the mass m, then the product of both we get the momentum. Then what is the unit of momentum? The unit of mass is a kg. Yes, P is equal to m into v. Then P is equal to mass of the or the unit of mass is a kg into the unit of velocity is a meter per second. Then the unit of momentum is must be kg meter per second. Kg meter per second. Then why we are known the knowledge, why we are required the knowledge about the momentum for the discussions of the second law. Second law is state that the rate of change of momentum is equal to the external force or the force of the body. Second law, rate of change of momentum is equal to the force of that object or internal force of that object. The rate of change of momentum of that object is equal to the internal force of that object. Then F is must be equal to the rate of change of dp with respect to time, that is dt. Then dp by dt is the derivative. Then the value of p is must be equal to m into v. That is p must be m into v. Then the m is the constant. We doesn't take the derivative of that constant or the derivative of the constant is must be 0. Then this taken a common. Then f is equal to m dv by dt. I will explain about the information of dv by dt. It is the change in velocity with respect to time is acceleration or linear acceleration. Then the force is must be equal to mass into acceleration. This is all about the second law of motions or Newton's second law of motion. The Newton's second law of motion is stated that the rate of change of momentum of that object is equal to the internal force of that object. Then F is equal to dp by dt, rate of change of momentum with respect to time. Then d by dt, the value of p is equal to m into v. Then d by dt is the derivative of the momentum m into v. M is the constant value. The mass of the object is must be constant, but the speed or the velocity of the vehicles must be changes. Then we taken the derivative of the changeable value or continuously changeable value or non-constant value, that is dv by dt. We know about the dv by dt is the acceleration. change in velocity with respect to time, or rate of change of velocity with respect to time is the acceleration, that is dv by dt must be a. This is all about the Newton's second law of motions. The Newton's second law of motions is used in the explanations of the object or study the force of the moving object. Then the third and important law, every action has equal and opposite reaction force. This is this last and third law of motions. Third law. Every action has equal and opposite reaction force. Every action has equal and opposite reaction force. The third law, Newton's third law of motions, is must be applicable for the rocket science. Whenever we are launching the rockets in the space, the rockets will be pushed down certain force or applying on the certain force of our earth, then the earth is must be applied. Consider, I will be drawn the certain diagram. This is the surface of earth and this is our rockets. At the time of the launching of rockets, these rockets are pushed on the surface of our earth or apply certain action force on the earth, then this earth will be again the apply certain reaction force equal and opposite in direction. Then these rockets are moving much more faster for whenever they are applying certain force, action force towards that particular surface. In the next lectures, we are discuss the uniform and non-uniform linear motions and the circular motions. What types of the aspects are depends on the circular motion, that is centripetal force, centrifugal force. These certain things are discussed in the next lectures. We are meeting in the